So this is what we're going to do today. Please. So we are going to have the density. I'm sure we went over, everybody was there. We went over the density. We know the density it's a fraction, or it is a, between, in other words, it is a fraction between the two, which is the mass of a volume. And then when we are going to measure them, either with the solid or liquid, if we have a liquid, the unit of the density will be gram per mil, using the milliliter as a unit. If we have a solid, then it is going to be gram per cubic centimeter. And a cubic centimeter, because we are going to measure the 3D, and then that's how we're going to accumulate cubic centimeter. As for the volume of the liquid, we can always use the cylinder, and these are the cylinders. So remember when we were talking about the measurement of the volume, and in your activity and PowerPoint you saw the volumetric flask. This was one of them. And I told you the cylinder is the most popular and you're going to use it a lot. So it is a graduated cylinder, so we can measure the liquid in this glassware. Now, with the measurement of the solid, and this is the technique that we're going to use, we have two ways of using it. Let's say I have a box, like this box. How are we going to measure the volume of it?
Height, width, and length.
Exactly, the 3Ds, right? So we measure with the ruler the height, the width, and the length, and that's how we're going to measure it. So this is one way. If it is going to be a regular shape that we can measure the 3D. What if we are going to have something like this? Like, the rubber stopper. The rubber stopper does not have a regular shape, not even a cylinder. So in this case, we are going to demonstrate the water displacement, and then we're going to measure the differences between the water in the cylinder before the object, and then you submerge the object, and then we will see water displacement. The differences between the two levels is going to be the volume of this object. So these are the different techniques that we're going to learn today. Also, we are going to learn how to weigh a liquid, how to weigh a solid, okay? So on your bench, we are going to have this kind of 3-beam. Have you seen the 3-beam when you go to the physician? Right? So this is the first thing they ask you to stand on the scale, and they will weigh you. So we're going to learn how to measure the weight with this kind of, the scale, or we have the electric scale, the digital. We have up to 2 decimal places, and we have more significant or more specific with up to 4 decimal places. So it depends on the size of the object. If it is very small, we use the more precise, remember, with the higher decimal places. But if it is not as small, we will use either that or the other one, which is the electric. Now, so we know what's the difference between the cubic centimeter and the milliliter, right? Cubic centimeter is equal, 1 cubic centimeter is equal to 1 milliliter. What are we going to do today? That's the procedure. So in your handout, if you don't have the whole full handout, you have your laptop or you have your cell phone, because this is what we did in the morning. You can always find it, okay? Open it under lab assignment 1 in your cell phone, or in your, if you are a group, one of you had the laptop, you can always see it. Number 1, we're going to determine the density of unknown alcohol. The unknown alcohol is under the hood. there is one bottle. This is unknown 1. If you look at the data sheet, supposed to have 2 unknowns, but we are going to use 1 today, okay? So in the data sheet, if you go there, you're gonna see it says, okay, you have sample 1 and you have sample 2. But we're going to have only 1 sample, okay? Over here in page number 9. That's the result that we're going to collect today and then present it here, okay? So we have 1 sample unknown of alcohol. We're gonna measure the volume in this cylinder. Now the cylinder that you're going to use is the small cylinder, this one. According to the procedure, it says you need 5 to 6 milliliter. 5 to 6 milliliter. But first you have to measure it when it is empty, and you have to measure it with the liquid. Then you subtract the amount or the volume or like the weight, sorry, of the container. That will give you the weight of your liquid. Got it? How about the volume? How are we going to measure the volume of that liquid in the cylinder? Cylinder is graduated, so you know how many mil you are going to measure, right? It says between 5 to 6 in your page number 3. That's the procedure. You got it, everybody? So measure it when it's empty. All right, under the scale, either this one or the 3-beam. And then you're going to pour 5 to 6. If you wanted to measure, if the measurement like 5.2 is fine. If it is 5.5 is fine, up to 6, right? Even if it is 6.1 is fine, you should be okay. As long as you're gonna write it down. So this is the volume, right? You put that amount. After you measure the cylinder when it is empty, measure it with the alcohol, subtract the 2, I'm saying about the weight, subtract the container, right, before and after, that will give you the weight of your liquid. So this is, now we do know the volume, and we know the mass, we calculated. Dividing the 2 will give you the density of that rubber, or whatever alcohol. Okay? Now, the other part is determining the density of the rubber stopper, this one. Every single one of these, like you guys, the group need one of these. You can always take it. And then in this case, we are going to demonstrate the water displacement. Okay? So we are going to have any amount of water. It's up to you. So I have 60, all right? I just put 60. You want to put 30, you want to put 50, you want to put any measure, like, just make sure that this is the initial volume of the cylinder, okay? Then you're going to tilt it, and then just let it go through, okay? Make sure that you're not going to splash the water, because this is a volume and you don't want to lose it. Now you see the level of the water went from, what was it? So it was 60, right? Went into, okay, so I have 1, 2, 3, 4, 5, 6, 7. It's like, 70, 5, 6, 7, 77, okay? So it was 60, went into 77. So what is the volume of this object? 77. Right? So if it is like, 77 minus 60 is going to be 17. So this is going to be the volume of your unknown rubber stopper. Now the weight, you're going to weigh it in those, one of these, like, scales. And again, you do the same thing. You have the mass of the rubber stopper, you have the volume of the rubber stopper, divide them, you will calculate and find the density. We do the same thing, that's part 3. Determining the density of unknown metal. So we do have these metal bars here, every single group will have one of them. And then you're gonna demonstrate the same exact technique using the water displacement, okay? Instead of the rubber stopper, you're gonna use that. Be careful, some of them are very heavy, so you don't want to break the cylinder. So, if I'm going to put a water here, make sure that you be very careful. Here we are, okay? Tilt it and then let it submerge very, very carefully, all right? Number 1, you don't want to splash the water. Number 2, you don't want to break the cylinder, okay? And then you're going to read the level of the water before and after. Subtract between the two, you will get the number of the volume for that particular metal. Now, we are going to measure the metal ahead of time, right? Before you submerge it, because, or if you did that, make sure that you're going to dry it with the tissue, because you don't want it wet, okay? Make sure it is dry enough, and then take it to the scale, and then measure the weight, and then you're going to do the same exact thing, mass over volume. Now, in that sheet here, there is asking you to identify the unknown metal. How are we going to identify the unknown metal if we don't know what it is? Anybody could tell me? Yes. What are we measuring? Density, right? So from the density, you will be able to tell what is the element that we have. Now from the weight, because that's a molecular weight. It's not the weight that we're going to measure. But remember when we talked about the density, that it is an identity? It's like we identify any substance. The first thing you're going to see in any of those chemical and physics handout is the density. One of the identification of any substance found or any element found in the nature, okay? Or even prepared or synthesized. So this is basically what we are going to do today. Do you have a question about what we're going to do today? Any question? Because I want to show you how to use these scales. If you never used it before. So you're okay now? And we know at the end, if you go to the number 3 of the data sheet, and page number 10, it says identify or the identity of the unknown metal. You're not going to be able to know what it is until you measure the density of that metal. Then you go online if it is not part of this table, because you have the table there in one of the pre or post lab. We have neptunium, we have nickel, we have osmium, we have zinc, and we have lead, but it could be anything else. Maybe it is copper or aluminum or something else, you know what I mean? But you can always find out. After you calculate the density, you can Google it, you will be able to find what is the element that you have in those metal bars. Okay? Now the other thing that I want you to know, I put 2 small beakers under the hood. What I want you to do, I want you to pour some of the alcohol from the bottle into the beaker, and then from the beaker into the cylinder, okay? Don't try to put it like, to pour the alcohol immediately. Those who do not have goggles today, you have to be careful, and we are not allowed to have you here today. Is that clear? Next time, but this is the first time. Next time, I'm not going to let anybody come in. I'm not allowed to share this morning the lab manager came in, he notified everybody in the class that we are not allowed to share anybody with our own, if we have, like in the division, used to probably. If you were here like 2 years ago, maybe, but not under these circumstances. We are not allowed, if anything happened, we will be held responsible. So I'm not gonna be able to share anything with you, any of the, if there are some. Is that clear? So next time, I want everybody to have your own goggles, okay? Your own goggles. And it has to be one of those, as I showed you here, this one. It has to cover all your face. And these are cheaper than the others. And again, as I said probably before, Lowe's will sell it for $2. Home Depot will sell it for $5. I don't know why it's more expensive. But anyway. So is everybody with me here? This is empty, right? Before you start, do you see those different scales here? One start at, like, you know, graduated 10 grams. This is 500 gram, and this is 100 gram. So everything should be with the zero when before you start. If you don't see the level, you see the level here? The line should be aligned with zero. I would try to, it's very, very sensitive. So let me sit down. And you see this one line is not aligned with zero. So I have to bring it up. Alright, so this is almost like, you know, with the zero. After you do that, and it should be on the zero, then, and everything is on zero scale, nothing is changed. You're going to put that one here, and then usually we will move the 10. If it doesn't move, I will put the other, like, you know, go into 100 to, like, you know, another 10, 20, 30, 40. So you see, went down, I'll go back, and come back here. And I'll bring this here. Okay, so now it's coming. So it's almost like 49.9. 49.9, okay? So this is 40, this is 10, but it is a 9.9. So that's how we measure it. So that's how we are going to use the 3-beam. The other one that we need to use is this one. The electric, it's going to have 2 decimal places, all right? So again, we're going to do the same thing. If we want to measure this guy, for instance, make sure that you dry it. And make sure that you tar it. You see the tar here, T? Has to be tarred before we use it. And 0. And then I'm going to put that here. So it is 9.06, okay? You do the same thing with the cylinder. If you want to try both, and then so you'll get used to it, okay? And so this is how we are going to use the balance. All right? Those are the 2 different types of balance. With the volume, we are using the cylinder, okay? Now, when you're going to measure 5 to 6, use the 10 milliliter cylinder. But for the water displacement, use the 100 ml cylinder. Is everybody okay? All right, so
I could pull up like like
I think one of the group doesn't have a 10 milliliter. Which one doesn't have a 10 milliliter cylinder?
We have one.
Oh, that's from the previous. You have one? How did you get to have one?
well, like try to put so see.
Well, this is what the student will do. They will take the unknown and measure the cylinder when it is empty on the scale. So they're going to take the weight, and then we're going to pour 5 to 6.
Yeah, so I think we
The unknown alcohol, and then weigh it again. And when we subtract the weight of the cylinder, we will get the weight of the alcohol. The volume of the alcohol is 5, then we are going to divide mass over volume, and that will get me the density of the rubbing alcohol. For part 2, we are going to use this kind of cylinder, which is a larger, and I actually just put 25 milliliter of water, and now I'm going to insert the rubber stopper. So we want to find out what is the volume of this after I weighed it. So, okay. And now 25 went into 30, that's 5, 6, 7. So it is 32 before and after. So it was 25 went into 32. So when you're going to subtract 25 from 32, you're going to have 7 milliliter. This is the volume of the rubber stopper. It's been weighted before, and it is 9.05. So we again divide the mass of the rubber stopper divided by the volume, which is 7. This will give me the density of this rubber stopper. So this is the techniques called water displacement. And we're going to do the same thing for the third part of this experiment, which is when we're going to have the determination of the density of the piece of the metal. So student will pick one of these metal bar, and it is unknown to us. So we're going to measure them in the scale. That's the weight of it. And we're going to demonstrate the water replacement, that what we did the same way with the rubber stopper. And then this is going to give me the volume of this. And then we are of this metal bar. Then we're going to divide the mass of it divided by the volume. That will give me the density of this metal bar. Once we calculated the density of the metal bar, we will be able to identify the metal from the density, the calculated density. So this is what we are going to do today for our lab 1, is the determination of the density for liquid and solid.
4.1.